Okay, so we are talking about the Pythagorean Theorem now. And I want you to write this as your title. And I can apply the theorem to determine lengths of unknown sides of right triangles. Now, I want you to know that this only works with right triangles. So if you have any other type of triangle, it's not going to work. So right triangles only. Now, a right triangle, you can see we've got the two sides here and this little box in the corner. That right there signifies that it is a right triangle. So keep that in mind. Now, we have a leg right here, and we have the other leg right here. Right directly across from the right angle is the hypotenuse. It is always opposite this right angle. Now, you've got your leg, your hypotenuse. This is leg A. This is leg B. The hypotenuse is going to be your C. Now, look at A and B. We can interchange those and make it B and A. So it doesn't matter if this one is A or B. It doesn't matter if this one is A or B. But the hypotenuse will always have to be C. So you have that. So sides A, B, and C. Now the Pythagorean theorem, a squared plus b squared equals c squared. And I'm sure you remember some of this. Now I want you to solve for x. Take a look at this one here. I've got a squared plus b squared equals, in this case, my c squared is x. I want to solve for my c squared. So what am I going to do? I'm going to pull out my Pythagorean theorem. A squared. So a squared, I'm going to use the 6 here for my a. B squared is going to be the 8. And equals c squared. There I have my x squared. So what do you think is our first step to do? 6 times 6 is 36. 8 times 8 is 64. X squared is x squared. So we have that there. When I add 36 and 64, I get 100. 100 equals x squared. Now I want to get rid of my exponent. So in order to get rid of the exponent, I am going to need to square root both sides. I have to keep my equation simple and balanced. So I am going to find the square root of 100, and I'm going to find the square root of x squared. I want to get rid of that exponent. 10 times 10 is 100, so 10 is my square root of 100. And the absolute value of x, remember these signs, these lines right here on either side of the x, means absolute value. The absolute value of x, so x squared, when I get rid of the exponent, I have an x here, and so it's x. This could be a positive x, it could be a negative x. So I've got 10 equals, right here, x, or 10 equals negative x, or x equals negative 10, sorry. So I know that this length can't be a negative number. So I'm just going to cross that one out, and I'm going to go with the 10. So that was pretty easy, right? Not too bad. Okay, so we're going to try this one right here. We're going to solve for y. We've got one leg is 4, one leg is 7. Now I'm going to pull up my Pythagorean theorem. I've got my a squared plus b squared equals c squared. And I have my two legs here. 4 is one leg, 7 is the other leg. So I'm going to have 7 squared plus 4 squared equals my y squared. This is my y, and I want to find out what that is. So I'm going to multiply it. 7 squared plus 4 squared equals y squared. 7 times 7 is 49. 4 times 4 is 16. Y squared is y squared. Adding those two together, I get 65 equals y squared. Now I'm going to turn and do the same thing as I did before. I need to get rid of that exponent. So to get rid of that exponent, I'm going to square root everything. I have the square root of 65 equals the square root of y squared. So the square root of 65, what is the square root of 65? It is y equals 8.1. About. That's not exactly. Now, when we have the absolute value here, I have both the positive and negative number, but I know that I'm looking at distance, so I know that I'm not going to have a negative one. So I'm crossing that one out. So my answer here is going to be x equals the square root of 65, or y equals the square root of 65, and y equals about 8.1. So it's not that hard. Okay, what if I want to solve for t? T is one of the legs. So I'm going to pull up a squared plus b squared equals c squared, so I remember what I'm doing. Now I have t squared plus 6 squared equals 15 squared. Oh, I have my equals 225 and I have a plus 36. Oh my, what am I going to do? I'm going to subtract 36 from both sides. And when I do that, I have t squared equals 189. I want to take that and get rid of that exponent. I get rid of the exponent by doing the square root of. So the square root of t squared is going to be t. The square root of 189 is going to be roughly 13.7, give or take. So it's not an exact, I believe there's more decimal points and we're rounding up. So let's look again. We've got that one. Not too bad at all. Now, I do want to talk to you about Pythagorean triples. Be familiar with these Pythagorean triples. We've got 3, 4, 5, 6, 8, 10, 9, 12, 15, 12, 16, 20, and this goes on and on and on. Those three numbers right there, 3, 4, and 5. Think about it. Now I have some more here, 5, 12, and 13, 10, 24, 26, 15, 36, 39, and that continues on. And then I have right here 7, 24, and 25, 14, 48, and 50, 21, 72, and 75, and that continues on. So what this is the sides of a right triangle. So if I have the sides of, like this one right here, one of my legs is 12, and my hypotenuse here is 15. So I'm going to look up here. I've got a 15 here. I have a 12 for one of the legs. These are my hypotenuse. The larger side is going to be the hypotenuse. Now I've got 15. I have 12. So guess what this side is going to be? You got it. It's going to be 9. So not too bad. Okay, so we're going to work on this problem right here. And to the nearest tenth of a foot, I want you to find the length of a diagonal of a rectangle with a width of 4 feet and a length of 10 feet. This is very similar to the question we had on that assessment where we had the ladder that was 12 feet and it was 4 feet on the wall, I believe, or against the house or whatever. I don't remember exactly. So now I have this here. So I'm going to try to figure this out. I've got 4 feet and I've got 10 feet. And I want to find the length of the diagonal right there. That's my diagonal. It goes from one side to the next. So I am going to look at my a squared plus b squared equals c squared. And I am going to put in my 4 feet and my 10 feet and my x squared. So 4 squared plus 10 squared equals x squared. Now I have 16 plus 100 equals x squared. Add that together, I've got 116, and so I'm going to square both sides. So my x equals the square root of 116, which is about 10.8. Not too bad. Okay, let's look at this one right here. A car drives 20 miles due east and then 45 miles due south. To the nearest hundredth of a mile, how far is the car from its starting point? Okay, due east, 20 miles. And then it's going to go sharply south, 45 miles. This is the distance that we want to figure out how far it is from the starting point. I put my a squared plus b squared equals c squared in there, so I know what I'm doing. And then I have my two legs, the 20 miles and the 45 miles. So I'm going to square those. 20 times 20 is 400, and 45 times 45 is 2025. Now, I don't know what the x value is, so I can't figure that out, but I can add the 2025 plus the 400, and I have 2425 equals my x squared. Now, when I want to get rid of my exponent, I'm going to square root both sides, and then I'll have x equals the square root of 2425. So what is the square root of 2425? Again, we're looking at about 49.24. So that is going to be our answer. Not too bad. Okay, so I want you to make sure you have this in your notes, and we are going to do a whole lot more stuff with the Pythagorean theorem. So I will see you next time.